Hi, I'm Mike Hoyer, HBK Applications Engineer, and this is a short video on an introduction and getting started with remote probes using a Genesis Dynamic Power Analyzer. Well, first, let's just do a brief overview on the why. Let's start with a comparison on the standard measurement versus the remote probe measurement for an electric drivetrain test. Now, the standard and cost-efficient method has high voltage and current copper cables running from the test point to the power analyzer using the most cost-efficient GM310B card with built-in burden resistors. However, to mitigate EMI issues and take advantage of all the numerous benefits in E-drive measurements, the next generation measurement method has high voltage and current cables a safe distance away from both the power analyzer and you, the user, by using remote probes connected to the power analyzer via fiber optic cables. Now, there are two variants of the remote probes, and we'll talk more about that in a moment. However, the many benefits include what you see actually here. We're talking about mitigating EMI issues, simplifying cabling. There's uncompromised safety for both the equipment and you, the user. You can measure up to plus minus 2,000 volts directly. And you can even sample up to 4 million samples per second. In fact, even 20 million samples per second with 2.4 megahertz bandwidth. You've got independent probe calibration capability, shorter cables preventing reflections. There's even an integrated CT power supply on the current remote probe, minimizing cabling. And you can have a distributed setup with cable lengths up to 328 feet or 100 meters. Now, as I mentioned earlier, there are two variants of remote probes. There's the standard 2 million samples per second, and there's the fast 4 million samples per second, which can actually record data up to 20 million samples per second. Now, before we address the differences, let's talk about the specifications that are common for both variants, which happen to include 4 channels on each remote probe. There's 3 for the output of the inverter and a 4th for the power source. Now, the voltage probe can measure up to plus minus 2,000 volts directly with a bandwidth of 2.4 megahertz, and the current probe can measure up to plus minus 2 amps from a CT using built-in high-precision burden resistors, or you can even measure up to plus minus 20 volts from a current clamp with a bandwidth of 2.3 megahertz. And there's even a current remote probe variant that includes an integrated CT power supply, further minimizing copper cabling. Now, power accuracy is an impressive 0.015% of reading and 0.02% of range. And specific to the standard remote probes is the 2 million samples per second sampling rate, which can perform real-time math. Now, this variant requires at least perception version 8.70 or more, preferably the version 8.72. Now, specific to the fast remote probes, they require perception 8.80 minimum and only have the ability to store raw data when sampling faster than 4 million samples per second, all the way up to 20 million samples per second. However, you can perform real-time math when sampling faster than 2 million samples per second up to 4 million samples per second with some limitations. For example, you need to use local storage via mainframe's optional solid-state drive, otherwise you'll see deployment errors occur storing to a PC location. Now, this ability is not supported on Gen 3i and Gen 2 TV mainframes, and minimum cycle frequency for fundamental optional analysis is increased to 20 Hz. And finally, for both variants, a GN800B fiber optic receiver card placed in the mainframe can be used for 2 remote probes, such as 1 pair of voltage and current, or 2 voltage probes if preferred. However, with perception version 8.82, you can connect up to 4 remote probes on 1 GN800B. Now, a typical ideal remote probe cabling setup would look something like this. For voltage, you can use 4 of the short half or 1 meter 2-wire insulated shielded test leads, cab 2121, to connect the voltage to the 4-channel voltage remote probe input. Then connect the output of the voltage remote probe to the mainframe's first port on the GN800B fiber optic receiver card using a fiber optic cable cab 280. Now note that each remote probe includes two SFP plus modules, one to be inserted into the rear of the remote probe and one to be inserted into the GN800B fiber optic receiver card. Now for current, with an embedded CT power supply remote probe, you can use 4 CT cables cab 2133 to connect the current from the CT to the 4-channel current remote probe input. Then connect the output of the current remote probe to the mainframe's second port on the GN800B fiber optic receiver card, and you can use a fiber optic cable cab 280 to do so. Now, you want to be sure and refer to the user manual for further details, such as inserting the SFP plus modules. Now, alternatively for current, if your CT power supply is not embedded in your current remote probe, then you will need to provide an external CT power supply as seen here and use the XLR to D9 cable from the CT power supply, also known as the interface unit, to the current remote probe input using a cab 2021 cable. Well, after making all the cable connections, including the voltage or current signals to the front end of both remote probes, the AC power cord and fiber optic cable on the rear of both remote probes, and all the appropriate connections on the mainframe, it's now time to turn on the power switch on the remote probes, followed by the power switch on the Genesis Power Analyzer mainframe. And you'll need to wait about 5 minutes for the remote probes to warm up and establish communication with the mainframe. Now, one thing to keep in mind is in order to perform power measurements with the highest possible accuracy, a factory power verification is performed using a specific pair of voltage and current remote probes. Therefore, specific remote probes become each other's companions based on their serial numbers and together form a power channel. Therefore, it's important to avoid swapping remote probes to achieve the highest possible accuracy, and if you'd like further details, you want to be sure and review the user manual. While the remote probes are warming up and establishing communication with the mainframe, you'll notice the change in the LED status on the remote probes and the front panel of the GN800B fiber optic receiver card. In fact, it's going to take about 5 minutes until both LEDs on the GN800B fiber optic receiver card to turn green, indicating the remote probes are online and everything is okay. Please make sure that the first port on the receiver card is from the voltage probe and the second port on the receiver card is from the current probe. Well, once both LEDs on the GN800B fiber optic receiver card are green, indicating the remote probes are online and everything's okay, well, feel free to start up and connect perception to the mainframe. Now, in this example, when I view a list of recorders within the settings sheet, I can see that my GN800B fiber optic receiver card in slot D of my mainframe is enabled and is of the type 20 million samples per second. And that means that the receiver card is capable of handling data at that rate, even if you're only using a standard 2 million samples per second remote probe. Now, when I view a list of the analog channels within the settings sheet, I can see a list of my voltage and current remote probe channels on recorder D, and all 8 have a power OK power status. The first set of 4 channels on recorder D are voltage, and the last set of 4 channels on recorder D are current. Well, now I enable and select the eDrive sheet, then double-click on the inverter element so I can select the appropriate channels for the inverter. Now, in this case, I select D02_123 for the current and D01_123 for the voltage. And in this example, I've decided to use the AC phase to ground connection for the measurement. Then I double-click on the power source element so I can select the appropriate channels for the power source. In this case, that's D02_4 for the current and D01_4 for the voltage. And I've selected the DC1 phase connection for the measurement. Now at this point, I just need to make sure that the appropriate current sensors are selected from the sensor database, and then I'm ready to acquire data. And of course, for further details, please review the remote probe user manual. Well, that wraps up getting started with remote probes. However, if you have any questions, please contact our support teams in North America. You can email support@usa.hbm.com or call toll-free 1-800-578-4260. And worldwide, you can email support@hbkworld.com, and be sure to visit our website to view our entire portfolio of solutions at www.hbkworld.com.